So for this video, I want to start the topic about HR diagram, which is the last major topic in this chapter. So before I start HR diagram, I just kind of want to review what we have learned so far in this chapter. What are the most important things in this chapter? So the major thing we learned in this chapter is about the properties of stars. Okay, so we learned about the size of the star, the motion of the star, the luminosity of a star, the temperature of a star, and how we can tell the temperature of a star, how we can find out luminosity of the star, okay, based on their sizes, actually based on the size and based on the temperature, as well as some other features. But the major thing you need to pay attention to in this chapter is, the first thing is the absolute magnitude, apparent magnitude. What's the difference between them? What kind of relationship do they have? The second thing is the luminosity dependence on the radius and the temperature. The third thing is how we can find out the temperature of a star through spectral classes as well as black body radiation. And then once we know the temperature and we know the size, we can kind of decide the luminosity of a star. So the next important topic actually we're going to cover today is about HR diagram. As we mentioned, there are so many stars in the sky. So how can we categorize all these stars? Okay, and then so once we categorize them, we can understand these stars much better. Okay, so HR diagram actually is a very powerful tool, okay, for us to first to categorize different kinds of stars, and later on we're going to learn that HR diagram is going to help us to understand the life cycle of a star, okay, and how the life cycle of a star depends on their masses. Okay, so if you, as you can see from here, okay, the HR diagram, okay, is named after two astronomers. So HR diagram plots the stellar luminosity against the surface temperature. In other words, the y-axis here is the luminosity, the axis here is surface temperature. Sometimes the x-axis could be spectral classification. Remember, we talk about from O to M. And then the y-axis could also use absolute magnitude to represent it. Okay. And again here, please pay attention to the luminosities in the solar units, and let's pay attention to where sun is located. So sun's temperature is about 6,000 Kelvin, and then the luminosity is about 1. Okay, so everything else is compared to the sun's luminosity. So this HR diagram shows you a few stars, and then they are kind of, you know, spread around on the HR diagram. As you plot more, and then you can see the patterns actually begins to form. Okay, so you can see a lot of stars actually, they are located on this called main sequence. So the stars which are located on this main sequence are called main sequence stars. Okay, and then you can see some stars over here, some stars over here. Okay, so for stars over here, we call them white dwarf stars. So what kind of properties they have? They have very high temperature, but they have low luminosity. So you can see here, they're on the left corner, okay, left lower corner of the HR diagram. So here we have high temperature, here we have low temperature. And then here we have high luminosity, and here we have low luminosity. So for white dwarf regions, they're not very luminous, but they're, you know, actually temperature is pretty high. On the other hand, if you look at here for the red dwarf, okay, the red dwarf has very low temperature as well as very low luminosity. So based on where the star is located, you kind of can tell the luminosity as well as the temperature of a particular star you're interested. As we plot more, okay, and then you can see there are some stars located here on the HR diagram. They are named as red giant region, okay? So the red giant actually have low temperature, they have high luminosity, okay? And then here, okay, we have blue giants. Blue giants means that they have very high temperature, they have very high luminosity. So most of stars are actually pretty young stars. Okay, and then when we call dwarfs and giants, actually we are talking about their sizes. If you see the dashed line over here on the HR diagram, you can see that. So when the lines here, they are meaning the star is actually smaller than the sun size. When it's when the lines are over here, so they are referring to the stars which are much bigger or bigger than the size of the sun. And as you can see here, so these are giants because they are bigger. And if you take a look at these, so these are actually smaller, so that's why we call them dwarfs. And this is an HR diagram which has about 20,000 stars. Okay, so as you can see, majority of stars are over here located on 90% of the stars lie on the main sequence, and then we have about 9% of the stars are red giants, and we have some actual white dwarfs over here. So from this diagram, you can see that, you know, roughly where the majority of stars are located on the HR diagram, and based on where they're located on the HR diagram, we can find out its corresponding luminosity as well as the temperature of the star. And next chapter, we are going to use HR diagram to talk about the life cycle of a star, and we will see more about HR diagram. But for this chapter, you know, we just start to get familiar with the HR diagram, as well as you need to kind of know, okay, where the main sequence star is located, where, you know, blue giant is red giant, white dwarf, red dwarf are located. The next topic I just want to mention very quickly, you know, we talk about this throughout the semester because the way how we measure an object in the universe, actually how far it is away from us, it really depends on how far the object is away from us. You know, we talk about triangulation method, we talk about parallax method, and then also we can use spectroscopic parallax method to measure it. So as long as you can measure the star's apparent magnitude and spectral class, and we can use spectral class to decide luminosity. So once we know luminosity, we can use universe square law we learned to find out distance. I'm not going to ask you to calculate the distance based on luminosity, based on the absolute magnitude, apparent magnitude relationship, but I want you to understand this is one of the methods actually we can use to measure a distance of some object which is very far away from us. For instance, like stars. Okay, as you can see here, this diagram shows you different kinds of methods based on different kinds of distances, which method we're going to use for what particular distance. Okay, so we talk about, you know, radar, we talk about stellar parallax, we talk about spectroscopic parallax, and so different distances, you're going to use different method to find out how far each object is away from us. Again, I'm not going to ask you to know the details about it because we are the 101 very fundamental class for astronomy. But the next thing I want to talk about is stellar masses, because this is a very important factor later on for when we talk about next chapter, we talk about life cycle of a star. Or stellar mass actually plays a very important role to determine how the star is going to evolve and eventually how the stars they're going to die. So as you can see, mass is the main determinant of where a star will be on the main sequence. As you can see on the main sequence, the lower mass is actually the stars, they're going to locate it over here, but the higher mass, they're going to locate it over here, which means the lower mass, typically they have low temperature and low luminosity. And if the mass is getting bigger, they're going to have higher temperature, also higher luminosity. And we know that this is where, like, you know, the young stars like to stay on the HR diagram. And that also tells you something about life cycle of a star. Okay. All right, so I think that's pretty much about this chapter. And then, as I said, the major topic we covered today is about HR diagram, and also you can find this tutorial exercise on the Blackboard I posted in the folder of this of chapter 10. So please find the worksheet for HR diagram and then please practice on it. I think you guys should be okay with this worksheet. You know, the purpose of this worksheet is, again, to get yourself familiar with the HR diagram and then prepare you to study the materials we're going to cover in chapter 11.